I'm Paul Epps, and today we're going to get a job with Google by acing one of their coding interview questions. This site is called InterviewBit. I think it's a pretty good site. One of the things that I like is um, they group interview questions by company. And so if you're interested in the interview process at Google, you can click into the Google interview questions. You can find out about their recruitment process, what kind of interview preparation you should be doing, frequently asked questions, and coding interview questions. That's what we want to look at. All right. So it gives us 10 questions. One of them is easy. That's probably a good place to start. So let's look at that. Majority element. Okay. Let's see. Problem description. Given an array of size n, find the majority element. Majority element is the element that appears more than floor n over 2 times. So the majority element is not the element that appears more than any other element. It's an element that appears more than every other element combined. And that's important in solving the problem. You may assume that the array is non-empty and that the majority element always exists in the array. And that's also important, that they will guarantee that a majority element exists. Input format, the first argument is an integer array A, and the output is the majority element. All right. So the most obvious way to solve this probably is with a hash map. A hash map is a very useful data structure in coding interview questions, or a hash table, or a dictionary in C#, or it may be called something else in your programming language of choice, but any data structure where you can maintain key value pairs. So in this case, we could use the integers in list A as the keys in a hash map. So each unique integer is a key in the map, and then the corresponding value would be a count of how many times did we see that integer as we were going through the list. Now we can take a pass through the map, and based on the counts, we can find the majority element. Okay, so the interviewer says, what's the runtime for that? And we've got to go through the list of n integers, and we've also got to go through the map. So, I mean, worst case is like 2n, but it's O of n. Any way you look at it, it's O of n. The interviewer then says, can you solve it with just one pass through the list and forget about the map? And yeah, I think we can do that. I mean, one hint here is that they've put it under the greedy algorithm category. We can use the fact that the majority element exists more than every other element combined, and we can use the fact that the majority element is guaranteed to exist. Okay, so the strategy really is we can pair off instances of the majority element with non-matching elements and just basically discard them. And once we've done that, The only thing that's going to be left is one or more instances of the majority element because it exists more than every other element combined. So to look at how the strategy might work, let's say we start reading the list. First element comes in and it's a 6. All right, so we're going to say that's the majority element. Well, that's the only element that we know. We're also going to keep a count. We're going to keep a count for the majority element. And the count is now 1. Next element, also a 6. Increment the count. It's 2. Next element, 7. That doesn't match the majority element. So the count goes down to 1. Next element, also a 7. Doesn't match the majority element. Count goes down to 0. Now we have no majority element anymore. But as I said, if we pair up instances of the, well, actually, let me hold off on that. Let's read the next element. Next element is, let's say, 8. All right, well, that's our new majority element, and we increment the count. Now, you might say, well, 8 is obviously not the majority element, and at this point, you're right. We could have 5 8s in a row, and in that case, it becomes the majority element. But for now, let's just go one step at a time. Next element comes in. It's a 6. Well, that doesn't match the majority element, which is now 8. So we've got to decrement the count. Next, so we have no majority element. Next element comes in. Also a 6. Okay, good. Increment the count. And that's the majority element. Now let's say that's the whole list. All right, so we end up with 6 as the majority element, and that's right. There's 4 6s and 3 other numbers. We're using the fact that again, we can cancel out one instance of the majority element for every non-instance of the majority element and still have at least one majority element left over. So, I mean, let's see how that looks in code. I'm gonna erase that, go up here and write some code. All right, so we need variables to keep track of 2 things. So one is, I might as well spell it out, majority elements. Let's just initialize it to -1. It's kind of we'll use that as kind of a marker. And then we need a count variable. Count will be 0. All right. Now a for loop to go through the list. For, I think we can do an enhanced for loop here because I don't think we need the index in the loop. So let's say for integer I in A. If the majority element equals -1, which means we don't currently have a majority element, then we'll set the majority element to I. That's our majority element. That's like when 6 came in as the first number. We set that to the majority element and increment the count. All right. Else, if. Well, if we get to this, that means we do have a majority element. And if that majority element equals I, then we increment the count. But if it doesn't match, then we decrement the count. And actually, there's one more thing here. Because we're using majority element equals -1 as a marker, then we have to say that if the count drops to 0, then we have to set majority element back to -1. And actually, that should be in the for loop. And then return majority element. All right. I think that will work, but we can streamline it by noticing a couple of things. One is that these two things are really synonymous. Majority element equals -1 and count equals 0. All right, we initialize them that way. Also, down here, when count goes to 0, we set majority element back to 1. Okay. So, and the other thing is that we have the increment in this if statement, and we also have the increment in this if statement. So let's try this. Instead of checking majority element equals -1, let's check if count equals 0, because it's really the same thing. And if count equals 0, let's really streamline it. If count equals 0, then majority element equals actually let's set it to I. Is that going to work? If count equals 0, majority element equals I. Yeah, that's what we want. But we don't have to set the count here. We don't have to set the count there. And then here, let's say if majority element equals I, then we'll increment the count. Okay? We don't have to increment it now in both places because this if statement sets majority element to I. So when we come down here and check whether majority element equals I, we know it equals I when count equals 0. So we can increment the count here just one time. Well, this probably isn't, like recommended coding style, but else count, else decrement the count. Yeah, that's fine. And we can take this out because we're not using majority element equals -1 as a marker anymore. So we don't need to do that. Okay. And you know what? I want to full screen this so I can see what I'm doing here. All right. Let's run it and see what happens. What is that? Not a statement. If count equals 0, majority element equals I on line 9. If count equals 0, majority element equals I. Oh, I see. Forgot to delete a C out there. Okay. Now let's try it. Success. All right, so it is trivially correct. So we can submit it and see if it's like deeply correct. Success. Test case. Easy, hard. Your answer is correct. All right. 6 hours. It didn't really take 6 hours. I think I just had this page sitting open all day. Okay. All right, so there it is. Next time we'll try one of the intermediate ones, and I'll see you at Google.